The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. Welcome to the NWS Boston webinar. Today we'll be talking about the April 6, 1982 blizzard. And so once again, thank you for joining us on a beautiful day here in southern New England. We appreciate your time as we go through this event. So just as a reminder, anytime you miss a webinar, you can go to our YouTube page, so youtube.com/NWS Boston, and you can go to our homepage to sign up for webinars. You can also email Joe, our Science and Operations Officer, and his email is at the bottom right-hand corner. So once again, the presenters tonight are myself, Rodney Chai, I'm a forecaster here at the Boston office, and also Joe Delicapini. He's the Science and Operations Officer. So just an overview of the this Northeast U.S. blizzard of 1982. It really was a 2-day event, April 6 to 7. High pressure over central Canada pushed just very unseasonably chilly air into New England on April 5th. And on April 6 and 7, so a low-pressure system emerged from the Gulf Coast into the Ohio River Valley, and then developed as a nor'easter off the Mid-Atlantic coast. And over a foot of snow fell across much of southern New England, with strong winds resulting in blizzard conditions. So you can take a look here. Some of the snowfall totals: Boston 13 inches, Blue Hill 14, Worcester 15, and 24 inches in Plainfield. And this single snowstorm put April 1982 as one of the top 5 snowiest Aprils on record for all the 4 major climate sites in southern New England. So Boston, Hartford, Connecticut, Worcester, and Providence, Rhode Island, as well as the long-term climate site that we have in Blue Hill Observatory in Milton, which is at 600 feet. So this snowfall accumulation map goes to show you, sometimes you just need one defining event in a season to really kind of like, there are different ways to put it: inflate the snow totals, or make it a memorable winter. Kind of like this past winter, we had the end of January blizzard, and really, which accounted for more than half the snowfall in Boston itself. And Boston is still running above, still ahead of Worcester, 54 inches to 53.6 inches for this season snowfall. We'll see if Boston can hold its lead to the end of the season. And you can see just so for Boston, you can see that brown line. That's the normal, in how normally from a climatological standpoint, how Boston accumulates its snowfall through the season. And you can see typically the snow machine really cranks up from late January into February. So for most of that season, 1981 to 82 winter, Boston, was basically on pace for above normal snowfall, and it kind of flattened out in in March. But that April 6 to 7 storm really just gave it a boost towards the end of the winter season, as you can see here. And Providence, it's so close to Boston, so climatologically very similar to Boston, maybe more removed from the sea breeze, but you can see similar story. Basically above normal for much of the season, and then an extra boost in early April from the blizzard. And then when we get further inland towards the Connecticut River Valley, you can see Hartford, Connecticut actually was kind of like hugging the trend line, and then went below normal from mid-February onwards, and then that dump of snow from the blizzard, made sure Hartford finished the season with above normal snowfall. So, like I said, um, it just takes one storm to define the season sometimes. And Worcester, 1,000 feet elevation. So, but it was again, it was kind of hugged the trend line through mid-February. Um, went below normal, but the April 6 to 7 storm made sure Worcester finished the season slightly above normal. So, talk about a tight finish. And then, this storm affected much of the Northeast and New York City, Central Park. It was a pretty unimpressive winter for them. I mean, they had 15 inches accumulation through early April. So, and then the normal snowfall, I mean, it was really closer to 30 inches. So that they received like 10 inches of snow. So that they ended the season below normal, but it's it looks a lot more respectable in terms of the snowfall department, thanks to this late season blizzard. And 1982 back then, I wasn't even born at that time, so it was a whole different world out there, and you can see the cars are totally different, and you can look at this was from WBZ, and very different. I mean, no fancy full graphics, and very basic models to look at, and very basic satellite images, as you will see in the coming slides. And this is what we had available for satellite data in 1982. And back then, satellite photographs were sent by fax. Now we can just pull up a website and we can see real-time satellite data. So talk about the rapid advancement in technology. And nowadays, it just almost kind of like an overload of data. You have to decide with your expertise what data to trust and prioritize over others. And in terms of news headlines coverage, it was quite an event. April snow is not that uncommon. Outside of the high terrain, generally 1,000 feet and below, we get 1 to 2 inches of snow on average. And typically what happens is that you get like a big event every now and then you get maybe flurries or trace of snow in other years in April, and it averages out to 1 to 2 inches. Average amount is kind of closer to 4 inches at 2,000 feet elevation. So for our friends out in Western Franklin County, that's on average you get about 4 inches of snow in April, because of the temperatures are marginal, so you need every bit of elevation to make sure you get snow over rain. So, but to get over a foot of snow in April, that's relatively uncommon, and it it will make a lot of headlines if it happens. So you can see again just some of the blasts from the past. I mean, it's just the graphics and look very different, but the story is, it was you can see the whiteout condition, and that's Manhattan right there, and here's a loop showing you would think this is straight out of midwinter. I mean, but was early April. And a lot of the cars back then, they have rear wheel drive, and so it's a lot trickier to get around in snowy conditions. More headlines from the New York Post and Daily News, just very blockbuster and high impact event. From the New York Times, rare April blizzard punishes metropolitan New York, and temperature was 21 degrees, so there was also a record cold as well, because there was an Arctic air mass in place that led to snow all the way down to the mid-Atlantic states and Cape Cod and the islands. And also, we're talking about April, so baseball season. So opening day for Major League Baseball in 1982 was postponed in many cities as a result of the snow and cold weather. In Chicago, the Red Sox opener was postponed due to the snow. In New York City, the Yankees opener, and Joe is a huge Yankees fan, um, the Yankees opener was delayed 4 days due to drifting snow and power outages in the Bronx area. And for our friends up north in Portland, Maine, they were also affected as well. So let's talk a little bit about the meteorology, why this event happened. And bear in mind, back then, there wasn't a lot of weather maps and data, model data to play with, unlike today. So, we did a lot of research and dig into the archive. So this is the best we can find, but we can still construct a pretty good weather story, how this event unfolded and blew up to it to such a great extent. So looking up at 18,000 feet above sea level. So this is actually closer to probably like 25,000 feet. This is 300 millibar height. The winds up there are very fast flowing, and we tend to look at the diagnostic atmosphere from top to bottom. And so you can see a very strong jet streak. So jet streak is kind of a small part of the jet stream that basically divides the warmer air and colder air. Warmer air to the south, colder air to the north. And you can see the strong jet streak illustrated by the brighter colors. So you're talking about winds that are in excess of 120 knots. And so the strong jet streak was diving south, east actually, from the Rocky Mountains. And that was April 5th, 8 a.m. So the event was April 6th to 7. And then, so in this case, apologies for the typo here. It really should be April 6th, 8 a.m., not March 31st. But the jet streak is now rounding the base of the trough. So you can kind of make out that trophy feature right here if you follow my mouse. And basically what it does, when it does that, it kind of reinvigorates the upper level trough, and eventually through the mixing of the winds at different levels, eventually makes it down to the surface and intensifies the low pressure system that we are very familiar with at the surface. And going forward again to 8 a.m. April 6th. So and here the jet streak kept moving along, and you can see here that the trough kind of acquired a negative tilt. So basically, when we say the trough goes negative, you draw a line. You can draw a line from the northwest to the southeast. That is the feature we want to see for an intensifying storm system here in southern New England. And then you can also see this very strong jet streak. In this case, it's moving offshore, but when it does it provides additional lift to the coastal storm located further north. So you can see start seeing the yellow color. That's 150 knots. That's just honking wind at that level. So going down a little bit to 18,000 feet above sea level, so 500 millibar height. So in general, when we talk about the higher you go up in the atmosphere, the lower the pressure. So in this case, 500 millibar, that's 18,000 feet. And you can see that upper level trough moving across the plains, and kind of very subtle again, talking about 1982 technology. So that's the best technology we had at that time. So and then 12 hours later, you can see the trough digging a little bit deeper. When you start to see some additional amplitude to the trough, it signifies an intensifying system, at least in the upper levels. In this case, across the upper Midwest. And then 12 hours later, April 6th, 8 a.m., start to get, you know, um, get into the actual storm itself. The trough is now over the Great Lakes, and you can see it's trying to close off here. So this is kind of still like an open wave, but when you start to see the isobars kind of becoming circular in nature, that indicates that the trough is closing off and really strengthening rapidly. So, top-down approach. So we talked about 18,000 feet above sea level. Now let's dive down to 5,000 feet, closer to where people actually live. So since, again, you can see since the low pressure system was west of New England, so you can see right here, right over Pennsylvania, this allows, and remember the flow is cyclonic. The wind flows counterclockwise around the center of the low pressure. This means that we are on the warmer side. So you have southerly wind off the ocean, transporting warmer and more humid air into our region. So bottom line, we have a lot of moisture to play with because of this southerly flow. And then 12 hours later, you can see, so I'm just going to toggle in between these two slides. So the surface low went from southwest Pennsylvania to southeast of Nantucket. So this is a situation where we say that the low kind of undercut us. It kind of tracked to our south, kind of parallel. So it exits the coast over New Jersey, tracks south and parallel to Long Island, and then keeps moving along. Now this means that this helps lock in the colder air from the north, and just basically eliminates any possibility of mixing or changeover from snow to a wintry mix or rain, even down to the south coast and Cape Cod and the islands. So colder air is now pouring into southern New England, and then so you have moisture and you have colder air. So that basically are the key ingredients for a blockbuster snowstorm. So we let's take a look at the sounding. And for those of you who are not familiar with what the sounding is, basically we get this graphs or plots from by launching balloons into the air. So this balloon would go a lot of times to get up to 40,000 feet, and before they burst, and then that radio sound, that equipment tied to the balloon, falls back to the earth. So as it does that, the equipment has the technology to plot basically what is the temperature profile of the atmosphere like as you go higher up into the atmosphere. So the key takeaway from here is that actually there are two takeaways. So notice that the two lines, they are kind of close to each other. So the line on the right, that's air temperature. The line on the left is dew point temperature. So when these two lines are close to each other, it means that the relative humidity is close to 100%. So the air is actually saturated. So it's loaded with moisture. And then the other thing is that that's notice this 0 here. That's 0 degrees Celsius or 32 Fahrenheit. So that's the freezing line. So on on an atmospheric sounding, so you want to find where the freezing line is. Look for the 0 on the horizontal axis, and then follow the line that goes from 0. Follow it to the top right. So just go along this blue line. So that's your 0 degrees Celsius line. And notice that the sounding is to the left of this freezing line. So it means that pretty much the entire atmosphere in Chatham was below freezing. So you're not going to have any issues snowing, and it's not going to change over to sleet, freezing rain, or rain. It's going to remain all snow. And let's take a look at the surface weather map on. So this is April 5th, 8 a.m. So notice you can see this low pressure system over the southern Great Plains, and eventually would strengthen and actually become the coastal storm for the northeast. And notice this high pressure parked over central Canada. Um, that's a very that's an anomalous high pressure in April, and this allows colder air to basically flood much of the eastern seaboard. Basically from the Midwest into the Northeast, and set the stage for our blizzard. So April 6, 8 a.m., you can see the low pressure has reached the mid-Atlantic coast and begun to strengthen. So and again, this is 1982 technology, so it looks a little bit dated, but you can still find the key takeaways on this map. You can see the isobars, again, the lines of constant pressure, are beginning to be closer to each other. That means that the system is strengthening. And you can see that warm front lifting northwards, and then the cold front following behind. And you see it on the north side of the system, you see the winds coming straight from the north. I mean, that's bringing in the very frigid air for it to snow. And 24 hours later, you can see that that low pressure kept strengthening, and as it exited into the Gulf of Maine and eventually Nova Scotia. And now you're looking at 972 millibar low. So, nowadays people like to talk about bomb cyclones. So this was a bomb cyclone because the pressure dropped more than 24 millibars in 24 hours. But really, what the key takeaway here is that the system was rapidly strengthening as it, exited the Mid-Atlantic coast and went up into the Gulf of Maine. So taking a look at some of the weather observations, and this is why it's so important. We really appreciate the hard work, and that our observers put in, because all this data goes into the nation's climate history. And now we are looking at, one of the reasons we are able to give this webinar tonight is because of all these observations. So that's why we really appreciate all our observers. So this was at Logan. So you can see where we had the red box here. That's the weather types that were observed. So S is snow. When you see a plus sign, that's heavy intensity. So S plus is heavy snow, and BS actually is blowing snow. And IP, that's sleet. So for a period of time. So the left column here, that's the time in. So you have to actually add 1 hour to it because this is central time. So kind of around like lunchtime, it was pounding, and actually you can see here. So there was widespread blowing snow. Visibility was down to 1/8 of a mile, and for the criteria for a blizzard is a quarter mile. So this is actually easily surpassed the basic criteria for a blizzard. And you can see here on the wind column. So you can see, I'm just going to take one row here. So you can see here this 276. That's in degrees. So 276, that's the direction the wind is coming from, and the 36 right next to it, that's the wind speed in knots. So 36 knots from 270 degrees. That's blowing pretty hard, along with 1/8 of a mile of visibility. So very nasty conditions. So looking at Blue Hill, 600 feet elevation, the snow was heaviest from 10 a.m. to 11 p.m. So that was a long time. And thunder snow was reported around 4 p.m. And there were some records set as well. So if you look at the notes here, the new record low maximum temperature of 28 degrees, breaking the previous record of 35. And remember, this is April 6th. Low minimum temperature of 16, beating the previous record of 19 degrees set in 1887. And then there was also that, the wind chill of minus 26, which is really a combination of the actual air temperature and wind speed. So it might be late season record. So going a little bit further inland, the T.F. Green Airport, which is the climate site for Providence, Rhode Island, snow was heaviest during the mid-afternoon hours into the early evening. And thunder snow was reported for an impressive 90 minutes from 2:45 p.m. to almost 4:23 p.m. So you can see TS, that's thunderstorm, and then you have you have F, that's fog, and SP, that's kind of a mix of snow and ice pellets. So yeah, I mean, either way, I mean, quarter mile visibility, are very nasty conditions out there. Worcester, 1,000 feet elevation, further inland, and snow was heaviest from 2 to 6 p.m. And there was thunder snow reported for almost 2 hours. So, I personally, I'm excited when I hear thunder in a snowstorm. But to be hearing thunder for nonstop for 2 hours, I mean that's very impressive. I mean that's a very dynamic storm system. I mean that's pretty much if you think about it, it's a strong thunderstorm, but it's puking snow instead of rain. So Hartford, Connecticut, this is Bradley International Airport in Windsor Locks, and snow was heaviest from 11 a.m. to 5 p.m. So a pretty high impact event. And finally, let's take a look at the New York City weather observations. Snow was heaviest from around 9 a.m. to 4 p.m. and there was thunder snow here. Look at the TS plus, that's thunder snow with a heavy snow falling, reported around 11 a.m. So this wraps up our webinar. And if you have any feedback or any questions, feel free to email Joe. His email is on the slide. And if you like this webinar and want to be informed when we organize new ones, feel free to email Joe, and he will add you to our list, mailing list, and you will get alerts when we plan for new webinars. So thank you for your time, and we hope you enjoyed the webinar.